Don't worry about that, okay? I'm not going to give you a pyramid that's like got blown over in the wind, okay? They're all going to be right pyramids. That's a pyramid. We haven't seen this shape yet, okay? It's got its own special little box in your formula sheet, okay? Sides are triangles. We have a height. When we talk about height, like what's my height? I measure it when I'm straight up and down, okay? My legs are right angles to the floor. I'm vertical. That's another way to say it, right? We don't take my height like this, do we? Okay? Seems stupid, but there's two measurements here. The height is always from the dead center of that pyramid to the top, straight up and down. There's a right angle there, okay? This is a different measurement. This is called, they're going to call it S. That's the slant height of one of its triangular sides. Okay? We'll talk more about that in a sec. Okay? Volume of a pyramid. Okay. This is a pyramid inside of a, what's another word for a box? What's the Math 10 way of saying that? You don't know that's a cube. But for sure, it's a rectangular prism. Okay? Might be a cube, might not be. A shoebox is called a rectangular prism. All right? How many of these pyramids do you think will fit inside of there? Because I'll tell you, it's a nice fraction. Does it look like half of the volume of that box? Does it look like a quarter, a third, 2/3? Anyone want to guess? Good guess. Looks like a half to me. He thinks it's a third. Well, I could tell you, but then I'd have to kill you. No, let's just have a look. Okay, because a picture is worth 1,000 words. And that should be working. There it is. Okay. What? Come on. All right, that's the one I want. What do we got? We got a pyramid. We have rectangular prism. What they're doing there is showing you that they have the same base size, okay? 15 seconds down, a minute and 5 seconds to go. Okay, there's the pyramid. There's the, what's it called? Rectangular prism. And we got to find out how many of those fit in there. So what better way than disgusting water? Yeah. Scope? Or is it just something with bacteria? Or maybe it's just food coloring. There's one. There's two. Oh, so it's more than a half as big. What do you think? Three. Or it might be four. Oh, keep going. Come on. That's not quite full. Yeah. Doesn't look like it, does it? 3 of those fit in one of these. With the same height and the same size base, 3 pyramids fit inside of a rectangular prism. And that's why we have this picture here. Okay? 3 of these fit in there. How can I say it the other way around? How many of these fit in that? Okay, does that make sense? Yeah. 3 of these fit in there, or what's the question? How does the volume of a pyramid compare to the volume of a prism? So remember, it has to have the same base area, and it has to have the same height. Okay? If it doesn't, then there's no relationship at all. If you remember this, it will be an easy mark on your test. Okay? And it will be on there for sure. And it's usually on the government exam as well. Okay? If you remember this relationship, Easy points. Okay? How does the volume of a pyramid compare? Okay, well, the volume of a pyramid is 1/3 that of a volume of the prism. Okay? Or, said the other way around, the volume of a prism with the same height and the same base is 3 times that the volume of a pyramid. Kind of spelt like pajamas, only you stop after the Y, right? Okay? PY. I know, my brain works weird. All right? Remember that. It's an easy mark. If you don't, you'll be sitting there for 10 minutes trying to figure it out. Okay, a cone. Guess how many cones fit inside of a cylinder with the same base area and the same height? God, you guys are so smart. Yeah, there it is, okay? Same relationship. Okay, what's the volume of this cylinder compared to one of those? It's 1/3 as big, right? What's the reciprocal of 3? 1/3. Okay, either which way you want to look at it. Simple little question. If the volume of this cylinder is 30, I don't know, centimeters cubed, what's the volume of one of these? Don't yell it out. Should be an easy mark. Bryce? Come on. Who was listening? One of these, because 3 of them fit in there, each one of these is 1/3 the volume of this. What's 1/3 of 30? 10. 10 and 10 make 30, okay? He knows it. I know he does. He was just sleeping. Okay? Should be an easy mark, guys. Just remember that relationship. Cones and cylinders or pyramids and prisms. Okay? It is cool, isn't it? Whose parents own Dark Side of the Moon? What's on the cover? Right? White light, when it goes through this prism, it gets refracted, is the word, into its different frequencies. So then you get your Roy G. Biv, right? The colors of the spectrum. Yeah, it's on the cover of Dark Side of the Moon. That's why it's cool. Pink Floyd's cool. Okay. Surface area and volume of these two shapes. Okay. Let's start with the easy one, volume. If you look on your formula sheet, find the pyramid. What does it say for volume? It says 1/3 the volume of a rectangular prism. That's what it says. 1/3 times base area times height. Okay? Okay, hang on. 1/3 times base area times height. Remember, for a rectangular prism, that's length times width times height, right? That's the volume. Doesn't matter what order you do it in. The base area is length times width, and I have the height. Now I'm just going to take 1/3 of it, okay, for the pyramid. That's where that comes from, okay? Do you guys, does yours say 1/3 or did they fix it? It is What are they missing here? Yeah. Area of base, not times height. Okay? So there's a little mistake in the book.
Let's get it right back.
Yeah. Well, I'll give you 10 cents of your 20 bucks. All right? Take out one page. Okay. Volume of a cone. Look it up. What does it say? Volume is 1/3 area of base times height. Hey, isn't that the same formula we just saw? Yes, it is. But what's the base area for a cone? It's a circle. What's the formula for area of a circle? Pi r squared times height. Okay? Does it say that in your formula? No. You need to know, looking at the picture of a cone, that the area of the base is a circle. It's pi r squared. Okay? We're in grade 10. I'm not going to give you, well, it's not me, it's the government. They're not going to give you every single formula written out like that. You have to do a little bit of thinking. Okay? This isn't given. This is 1/3 base area times height. The base area is a circle. This is on your formula sheet, area of a circle, but you got to find it somewhere else. Okay? So 1/3 pi r squared times height. 1/3 base area times height. Okay, those are the easier ones. Surface area. Add up all the surfaces of all the sides. That's what some of the other ones say. For a pyramid, okay, we have a base and the area of all the triangles. Now, if you're lucky, like the example I'm going to give you in a sec, this will be a square base. So what do I know about all 4 of these triangles? They're going to be the same. So all you got to do is find the area of 1, times it by 4, and that's what this says. Don't worry, we're getting to our example in a sec. Okay? This is the weird one. Surface area of a cone is area of the base. What's that? Pi r squared. And the area of the curved surface, what's another word for the top part? Who remembers? Starts with an L. Lateral, yeah. Also known as the lateral part. Okay, we're not going to prove this. Just go with me. That's pi times r times s. Okay, what was s again? Have a look at our picture. There's our cone. Height is always from the center, makes a right angle with the ground to the top. Slant is this dimension here. Okay? Don't call it the height, because we don't want 2 heights. Get all confused. That's the slant. Okay? Height. Let's not use the word height. Let's just call it slant. So don't worry about where it came from. Okay? That's just what works. We're not going to prove it. Okay? We have 2 parts there for surface area. We have the lateral part. Okay? And then we have the base. Read the question. Maybe it just says, I don't want to paint the bottom of this cone-shaped silo. I just want to paint the top part. You need to know, I'm not going to have this part here. I'm just going to have the lateral part. Okay? Don't need to know where it came from, but you need to know what part stands for what. All right? Okay. 2 little examples, and you're on your own. Let's do the easy one first. A cone, and the procedures, guys, the concept here is exactly the same. First step, what shape am I talking about? Is it a pyramid? Is it a cylinder? Is it a sphere? Is it a prism? It's a cone. Okay, pull out your formula sheet. Find the shape. Cone. Looks like a cone. Okay? That's step 1. What's step 2? Has a height of 15, diameter 16, determine the volume, and surface area. So it's like 2 questions in 1. Okay, that's step 2. Find out what they're asking for. I got the shape, I want to find the volume. What's the formula for volume of a cone? You look it up on your formula sheet. Here's all you have. 1/3 area of base times height. Okay? What's the area of a base of a cone? It's a circle. What's the area of a circle? Pi r squared times height. Okay. To get the volume, I need r and I need h, the height. Am I given it? Yes. The height is 15. That's from the center to the top. Okay? Radius. Do I have the radius? I have the diameter. Do I want a diameter? No, I want a radius. So if the diameter is 16 from edge to edge, I just want the radius, which is half of that, okay? Radius is 8. Why even put the diameter in my picture? I don't need it. Then, substitutions. 1/3 times pi, what's the radius? 8. Are we using brackets for our substitutions, guys? Yes, we should. Times height is 15. Okay, so let me write it over here because I might need some room for surface area. So the volume is, what's 1/3? How do you put that in your calculator? This is worth showing you again. How do you put 1/3 in your calculator? One divided by 3. There's a third. What's that as a decimal? It's that. Do not use 0.3. Okay? Don't do that. That's an approximation. You're going to use that number times pi. Okay? Times 8 squared. Or 8 times 8, if you like. Times 15. Okay? Read the question. Do I want that whole number? Tenths? What do they want? To 1 decimal place, which is 0.3, right? 1005, 0.3. Do I have units? Yes, I do. Centimeters, volumes 3 dimensions, centimeters cubed, right? Okay, everybody agree with that? Okay, surface area. What shape am I talking about? A cone. Look it up. What's the formula? Surface area. Pi r squared plus pi r s. All I need is r and s, and I plug them in. Do I know s? What is s again? It's the slant. Okay? Where's that? Oh, that's this guy. Is there a relationship here between s, h, and r? Pythagoras. S squared is h squared plus r squared. Wait. Okay? Circumference is s, right? That's always opposite the right angle. That says c squared is a squared plus b squared. But why use a, b's, and c's? Let's put in these ones. S squared is h squared plus r squared. Okay? So let's go back here. I need to know s. Well, if you want, redraw your triangle. That's 8. That's the radius. The height is 15. I'm trying to find the slant, the hypotenuse. Okay, so s squared is a squared plus b squared, if you want. Okay. 15 times 15 is 225. 8 times 8 is 64. That's what s squared is. So s squared is 225 and 64 is 289. Do I want s squared or do I want s? Yeah, s. How do I find s if I know s squared? Square root both sides. The square root of s squared is s. What is square root of 289? It is 17. That's a nice triangle. 8, 15, 17 triangle. It's nice because there's no decimals, right? It's like a 3, 4, 5 triangle. Okay, that's what s is. Now, surface area, pi 8 squared plus pi 8, sorry I didn't use brackets, I'm getting lazy, times 17. If you got a good calculator, all you have to do is plug it in. If you got a dollar store special, then you're going to have to do it in 2 steps. I don't think I can do that. I got to put times in there. Okay. To the 10th spot, 628.3. What's the units? Centimeters. Area has 2 dimensions. Squared. What? Okay. Wait till the pyramid. Okay. Like I said, it's worth repeating. Everything you do here for surface area and volume, the procedure is exactly the same. 1, find out what shape you're talking about. 2, is it surface area or volume? Look it up on your formula sheet. Get the formula. Okay. Then it's just substitutions. Maybe we have to do Pythagoras to find one of the dimensions. Okay. But that's the procedure. Okay. The big daddy. The big kahuna. And unfortunately, they're not giving us a heck of a lot of room here. The Great Pyramid of, is that Giza? Giza? The A, doesn't the A make the I long? Who's English major? Giza? Whatever. Blah, blah, blah. Is considered to be one of the 7 wonders of the world. Because, think about it. 147 of these. Is that pretty tall? Yes. There's 2. 145 more. That thing is pretty big. Okay, it probably took a crew of 1,000 people 50 years to build it type thing, right? You know? Has a square base. Okay. That's a nicer one. With sides measuring 440. All right. Make a sketch. Okay, you paying attention? Do 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 do. A little crooked, but not bad. All right, let's try it again. Hey, solid, solid. I think that one's going to be crooked too. Yeah, it's not bad. Like I said, they're all going to be right pyramids, right? They're not going to be crooked ones. There's not a lot of room here. Okay, sketch of the pyramid. 2 steps. Okay, first volume, then surface area. Let's do the easier one first. What's my shape? Pyramid. Look it up. What's the formula for volume? Volume is 1/3 that of a prism with the same dimensions. Base area times height. Okay, what's the base area? My base is a square. Each side is 440. That's 440. That's 440. Okay? So my base area is just a square, right? Volume is 1/3 length times width. What's the height? Does it tell me? 147. Okay. From the center to the top, that's supposed to make a right angle. That's 140. You shush it. That's 147. Okay. So, piece of cake. I'm given everything I need. All I got to do is put that in my calculator. Okay. 1 divided by, whoop, not answer. 1 divided by 3 times 440 times 440 times 1, I missed a 0, times 147. Ooh, that's pretty big. What's the units? Meters cubed. That's 9 million cubed meters. That thing is big. Well, it's not solid. It's partly hollow, right? But yes. Is that what they made it out of? Limestone? Lots of limestone in Egypt? Yeah, 9. What do I want my answer in? To the nearest cubic meter. Oh, that's nice. It doesn't even come in a decimal. 486,400. Meters cubed. Okay? That's a big pyramid. Can hold lots of bodies in that one. Probably built for one, though. Okay. That's the easy one. Surface area. Okay, you ready? Make a sketch of the net. Why are they asking you to do that? Because a picture is worth 1,000 words. How many sides does this guy have? 1, 2, 3, 4, 5. How many sides does the pyramid have? I don't know. Let's make a net and find out. If I slice it all up and fold it down, that's what it will look like. Okay? Count them. 5. Well, are you using a ruler, Emily? That looks perfect. I'm going to come over and look at yours later. Okay? Now, when it says surface area, again, think common sense. I'm not going to worry about explaining why the base is not included. Let's just say the base is not included in the calculations, okay? Are we going to pick this thing off the ground somehow and, like, I don't know, try to treat the bottom so acid rain doesn't disintegrate it anymore? No. Okay, so when it says surface area, all we want is the lateral area, okay, the lateral part. In this case, that's just 4 triangles, isn't it? Now, lucky us, I don't want this one, okay? Because this is a square base, what do I know about these triangles? They're all the same. They're all the same, right? That's 440. That's 440. I need the area of one triangle, and I need to multiply it by 4, right? 1, 2, 3, 4. So what's my formula for area of this triangle? 1/2 base times height. Okay. Do I know the base of the triangle? Yeah. 1/2 base is 440. Height. That's always at a right angle to the base. Do I know this dimension? Is that 147? Good. Here's the tricky part. That's not 147. Have a look at our wee little picture. This height is the height of the triangle. That's here. That's the slant height. Let's go right back to the beginning. The height of this triangle is this, right? That's the slant. That's not the height of the pyramid. Do you see a relationship here? Yippee! Pythagoras again? More than once in one class? This is awesome. Get paid. This will get you a good job, so you will get paid. Then you can do Pythagoras all day long. Okay? So this is hard to visualize. I'm going to blow up. You see this triangle here? That's a right angle triangle. I'm going to blow this thing up a bit. All right? I'm going to redraw it right there. Okay? I want to know the slant. That's the height of this triangle, this face. I know the height here is 147. That's a right angle. What's this distance here? That's from here, the center, to the edge, right? Half of 440. Okay, does everybody pay attention? Everyone see that? Wait, this triangle. All right, I need to find that. I need to find the hypotenuse. Okay, this is 147. That's fine. That's the height. Okay, I got to have two of these dimensions to solve for the third. I need this, but this is, remember, from the center, right? That's the height from the center to the top to the edge. Well, if that's 440 and that's halfway, what's half of 440? That's 220. Now you see how fun this question is? Okay. S squared is 147 squared plus 220 squared. Okay. So S squared is, what's 147 squared? Well, I'll do it. 147 squared plus 220 squared. Is that 70,009? Okay, so what's S? How do I get S if I know S squared? Square root it. Okay, what's the square root of that? The answer. It is 264. Do I want to round this answer to the tenths? Don't. Okay, take at least a couple of decimals or your final answer will be out. This isn't the answer. I just need this number to get the answer. So let's go 264.59. Okay, that's the slant. That is the height of this triangle. That goes here. That's the area of one triangle. Better yet, don't clear your calculator. Use that number and just calculate the area of the triangle, right? I already have this. This is going to be even more accurate. Times 440 divided by 2, right? 2's on the bottom. You want to multiply by 0.5, that's the same thing. Okay? That's the area of one triangle. How many do I have? Yeah. So that number, I need to multiply that by 4 to get all 4 surfaces. So don't clear your calculator. Now this is pretty close, oh, come on, to exact, if it works. Oh, good. Oh, well, I blew it. I'm not redoing it at all. Okay, 5, you can't even see that, it's off the screen. There we go. 5, 8, 2, 1. Do you notice I have to double tap every button on this? Yeah, because it's a computer program, it's not an actual calculator. That's why it's like, you guys are going, well, is he old or what? Like, it's taking him forever. So his fingers don't work anymore. Okay? All right, that's the surface area of just the top part. 232,841 point. Oh, I wanted the nearest hole. Nearest square meter. Okay, 238,841. 232,841. Okay, what's the units? Square meters. How fun was that, guys? That's not as hard as it could be. How could we make this one bit harder? If it's not a square base, these aren't the same dimensions. These are two different triangles. This one will be the same as that one, but this one is different. It will be the same as this one, but you just got one extra calculation to make. Okay? Okay? So, yep. Yeah, hexagonal, but we're not going to do those. Okay? I could have as many sides as you care to dream up. Octagonal? Yeah, no, don't worry about it. That's as many as you're going to get. Okay. That's enough for our brains, I think. So I'm going to shorten this down because we got not much time left, okay? 1 to 3. If you really want an A, do number 4. If when you guys get done, there's a review package here, okay? And if you guys are getting, learning what I do here, how close do you think the test is going to be to this thing? Yes. Don't wait till tomorrow to start this, because we might have a quiz, okay? So when you're done, start this, do a little bit tonight. This is what your test is going to look like Friday, okay? Surface area and volume, any shape except a sphere. It's the only one we haven't done.